Hi there, this is Kev. So in this video, I'm gonna talk about some of the concepts related like weather and climate, composition of atmosphere, and structure of atmosphere. So let's get started. So once I discuss here, you can go with the NCRT. I'll discuss only here, fine. So you guys might have heard about it, weather versus climate. Let me see, is it visible or not? It's not so visible. Okay, perfect. It is weather versus climate. Think about that. What does mean weather and climate? Let's discuss first weather. Weather is a day-to-day phenomena. Day-to-day phenomena. Fine. And it varies from places to places. Places to places. You may have you ever heard that the climate of today is like anything like that. We say weather, like that. And in climate, climate is the average atmospheric condition of let's say last 30 years. Fine. So this is the main difference. Here we take last 30, 40 years of the last 30, 40 years the climatic conditions. We take the average of that. But here it's a day-to-day phenomenon. Fine. And what are the factors that influence the climate here? We have rainfall. We have temperature. Actually, it's a precipitation. It would be better to write precipitation. And then we have pressure, humidity, etc. These are the factors that influence the climate of particular place. You find in the book Jishirun, in which it mentioned that the British has no climate, it has weather, and Egypt on the other hand, conversely, on the other hand, it has no weather, because it is static. So it's something like that. I'm gonna read it out. Like the climate of British is so changeable that many people have commented that Britain has no climate, only weather. Conversely, the climate of Egypt is so static that it makes a good deal of sense when people say that Egypt has no weather, only climate. So I hope I made it clear that weather is a day-to-day phenomenon, and climate, we take average last 30, 40 years of average condition of that particular place. Fine. So let's discuss what's the composition of atmosphere. This is basic, I just know. Now I use a action. Composition of atmosphere. Fine. First of all, guys, before going that composition, you should know what is atmosphere. So what does it mean, atmosphere? Think about this, something that comes to your mind. What do you think about atmosphere? I'm gonna tell you here. So what is atmosphere? Look guys. Again it is, I'll make it dark. Let me see again if it's visible. I hope so. Yeah. So this is Earth, fine, and it has a radius of around 6,003 kilometers. 6,300 kilometers is the radius of the Earth. Fine. So imagine guys. So what is atmosphere? Atmosphere is the envelope of the gases that surround the Earth. Fine. So you can write it down. It is the envelope of the gases that surrounds the Earth. So this is atmosphere. So what is atmosphere? The envelope of the gases that surrounds the Earth. We call it as atmosphere. So imagine guys, this is Earth. So how much height these gases can be found in the atmosphere. Can you imagine? Let me tell you guys. Fine. Okay, let me just make it. Fine. This is 64,000 kilometers where we find the presence of the gases. This is what we call atmosphere. The reach of the atmosphere is still 64,000 kilometers. Fine. Actually, the major gases are present only up to 80 kilometers, but gases are found. That's why it's the boundary of the atmosphere. We can say like that. Fine. So, what are the gases? I'm going to discuss it one by one, and if you find it relevant, you can note it down. Fine. So, okay, guys. I mean, this much height we find the gases, and can you tell me that why these gases are surrounded the Earth? I mean, why don't they go somewhere else? In what the force says, or anything like that that is binding, in this envelope. So why is it like that? Why these gases surrounding the Earth? Why these gases are surrounding the why? Guys, think about it. A simple reason that everybody knows that because of due to gravity, these gases are, due to gravity, these gases are surrounded the Earth because these gases have some amount of masses, some amount of mass. Not saying that much large mass, small amount of mass. So that Earth will exert that pressure. It means Earth will pulling these gases towards its center. So that's why these gases are enveloping around it. Fine. That's the reason behind it. Now I'm going to give a list of these gases. Fine. I hope you understand that. So I'm going to give a list. You can write it down. You will find it on NCERT. There is a permanent gases in atmosphere. These are the permanent gases. So permanent gases of atmosphere. First one is everybody knows like nitrogen. How much percentage is there? 78 point. It's the nitrogen. Its composition is around 78.05. But you don't need to go that more precise. Just remember it, fine. Then we have this O2 oxygen. It's around 20.95. Then we have argon. It's around. Let me see the composition. Just have the data here. It's a 0.093%. Then we have CO2. It's a carbon dioxide. It has around 0.001%. 0, 3, 6. Then we have, guys, just remember, these gases. After that, you can remember the order. Fine. Then we have, this is neon, no visible. You can remember like neon. Then we have helium, krypton, krypton, and xenon. Fine. Just remember the order of these gases, and you can remember, the percentage as well. Look, guys, nitrogen, and now I'm going to discuss one by one. Where do we get this nitrogen? Earlier, oxygen was not present, and so where did we get this oxygen? You will say that. When the origin of the universe, the oxygen was not added at that point in time. So where did we get it? We get it through photosynthesis. Photosynthesis, fine. And CO2 earlier, it had a large amount of CO2. Its amount has been reduced. How did it reduce? Due to we can say precipitation, or we can say rain, fine. Because what happens that there was in atmosphere CO2 was there, so when due to rain, what happens? This CO2 get dissolved in it gets down in the ocean, so oceans absorb this CO2. Fine. Then these are the neon, helium, and krypton. You can remember. Just remember that at like 78% is a 21, around 0.93, 0.06. After that, you can remember that order. That will discuss. Now let's discuss, some of the properties about these things. These gases. Let's take one by one. Sometimes they ask questions. They display some kind of statement in PT, so it would be helpful. Fine. What is nitrogen? So think about it. Anything like that. Where do we get it? So, as I mentioned that. So 0.8%. This is the percentage in atmosphere. Right? It's another gas. It do not react, guys. Fine. It subdue, or we can say it we can say reduce, or it controls the reactive nature of O2. O2 is reactive chemically, because O2 is reactive, so it subdues the reactive nature of this oxygen. Right? It is one of the essential gases that helps in amino acids like DNA, RNA. And one more thing, guys, where do we get this gas? Nitrogen cycle, of course. These are the sources. One more thing, guys, this gas is, obtained from degassing. Degassing, this is the first source. The second one is weathering of igneous rock. Let me just write it here. gathering of igneous fine. This is all about nitrogen. You can see the percentage. If inert gas is not reactive, it controls the reactive nature of oxygen. Then where do we obtain from nitrogen cycle and this degassing, and then we have gathering of igneous rocks. Fine. This is all about nitrogen. Let me see if there are any percentages left behind. I don't think so. Yeah, that's fine. It's all about nitrogen. So let's come to the next one. Next one is O2. So oxygen. So we want to add an NC percentage 20.95%. So where do we obtain from? Photosynthesis. Fine. And it is absorbed by during respiration. During respiration, consumed by, it is consumed during respiration by plants and animals. Right. During respiration, plants consume some amount of oxygen, and obviously these animals, they also consume. Any other things that you guys want to contribute here? You know that is a reactive in nature, capacity to react. Fine. Any other thing that you guys would like to contribute here? Fine. So this is all about oxygen, guys. Okay, after that we have this CO2, carbon dioxide. And sometimes question ask about this, or you find some statements related to this synthetic. So let's discuss it. Fine. CO. What's the percentage? We know that how much? 0.036%. What else? Is just a number. What else is? Absorbed by plants during photosynthesis, right? It is called as greenhouse gas. This is a greenhouse gas. What is this greenhouse? It absorbs the heat, right? Once it absorbs the heat, in atmosphere, then what will happen? You know, it's like that, guys. Uh, when it's a greenhouse gas, fine. Let's remember that. It's a greenhouse gas, then what will it do? It's going to affect the heat budget of Earth. Then going to affect the heat budget of the Earth. What is this heat budget? I'm going to discuss in the next topic. The very next topic is that heat budget. Fine. So anything else? I guess this was about this. Sure. And then you can remember these noble gases. They are not reactive. Fine. You can just remember the not sequence. They just don't react. This is all about. And one more thing, guys. Like I said, that the composition of atmosphere. I said these gases like oxygen, nitrogen, these noble gases. In addition to these, there are two more gases that I just forgot to tell you. Now, what are these? They are water vapor. Hang on, people. Okay, man. Now, the two, in addition to the, we have discussed, the gases like oxygen, nitrogen, and carbon dioxide, and then these noble gases. We have two more gases. What are these? Water vapor. Now, what is this water vapor? It is water in gaseous form. This is the first. Second one is dust particles. Here comes the question. Sometimes question, has been asked from these, two topics. So water vapors, let's discuss about it. Water in gaseous form is called as water vapor. Fine. It is the most variable. These two. These two most variable gases. These two are most variables. Fine. And they vary from place to place and time to time. Fine. Now let's discuss about particularly water vapors. You know that water in gaseous form is called water vapor. Vary from place to place and time to time. What else apart from that, guys? This depends on some factors like what are the factors like evaporation, fine, precipitation, temperature, etc. These are the factors that this water vapor depends on. Then we have, and this water vapor concentrated only till 16 kilometers. How much? 16 kilometers. Yeah, it's a 16 kilometers. 16 kilometers has 99% of water vapor. And if you go, Below that, you'll find 90% of water is confined only to 6 kilometers. Fine. And this is important, guys. It causes all the water phenomena. It causes all the weather phenomena, not water phenomena. Weather phenomena. Fine. What else? It is also a greenhouse gas. Most important point. I'm gonna write it here. It is also a greenhouse gas. It absorbs the heat. Fine. What else? Let me see there any point. I've got all the points. So, let me water vapor, water and gases from which full air. Water vapor, fine. Depends on the factors like evaporation, then we have precipitation, we have temperature, fine. The amount of water, etc. It is also greenhouse gas. Then it varies from place to place and time to time, and it causes all the weather phenomena. This is the most important factor. Here our all UPSC, trap you like only, all, none, these kind of words, fine. So this is all about water vapor. Let's come to that one, dust particle, fine. Yeah, this page is from here and there. And so dust particle, try to think about it, right? Dust particle, fine. I need to get it now. So we don't want to use it, but I have to use an option. One option, that is an option. No. Yeah. So write this particle. So dust particles vary from place to place, time to time. And so these dust particles, these are very tiny, minute particles. Very tiny, minute particles that are suspended. They are suspended in the atmosphere. Right? So they are very minute and tiny particles that suspend in the atmosphere. We call them as dust particles. What else? Actually, where do they originate? What's the origin of this? First is they originate from arid region, and the second one is to volcanic eruption. So arid region and volcanic eruption Guys, they may ask like, uh, they will give statements like 1, 2, 3, 4. One of them could be like that dust particles is not originated from volcanic eruption. So is it right or wrong? It can be a statement like that. Fine. This was the origin, and they are very minor, tiny particles. One more thing, they are hygroscopic. Actually, what is it? It's hygroscopic in nature. What is in hygroscopic? Let me just write it. Hygroscopic in nature. What does it mean, hygroscopic? It means they absorb the water. What does it mean? It means they absorb the water. So write like hygroscopic is one that absorbs the water. Yeah. They have the capacity. So you can write having the capacity to absorb the water. And this one is hygroscopic. So one statement can like that. Water vapors are hygroscopic in nature. So it could be, they can frame question like that. Fine. So this is all about the like dust particles. Is there anything left? Let me see. No, aren't there. So let's see some variations. This is a composition. In composition, you will find some variation. So variation. Think about it. How could this variation be there? Fine. So let's discuss. First of all, with time. Guys, with time you might have heard of this. News. You see news like CO2 level is increasing. Last couple of years, CO2 is increasing. So this is the variation. Fine. What else? You might also thought that O3 ozone layer is depleting. So ozone is decreasing. Fine. CO2 increasing, O3 is decreasing. Fine. And let's talk about with altitude. Some of the variation during altitude. So with altitude, when we go upward in the atmosphere, these dust particles and water vapor starts decreasing. So with altitude, what happens? Water vapor and dust particles decreases with increase in latitude. Fine. So with time, CO2 increasing, so ozone depleting or decreasing. Altitude, water vapor and dust particles, when you go up in the atmosphere, the amount of these two decreases. Fine. Let's talk about longitude. What's the effect of longitude? Is there any effect on longitude? We have that variations with longitude. One more thing, guys. Here altitude is O3. This is ozone. It is concentrated only in a particular belt. Fine. So a variation with longitude. So longitude, guys, that was previous altitude. Yeah, that's it. There is no variation on longitude, guys. Yeah, just variations. Oh, guys, I made a mistake. Use longitude. Because longitude, when we go up in the atmosphere, is long. When we go upper in the atmosphere, so the amount of these two decreases. This was longitude, not latitudinal height. Longitude when we go in upper height. Latitudinal variation. Let me see if it's visible or not. Yes, it's visible. So these water vapor, they are concentrated only in equatorial and subtropical regions. Equatorial and subtropical regions. Fine. What about dust particles? They are concentrated in subtropical regions where hot deserts are there. Subtropical regions where hot deserts are there. Fine. So guys, this is variation. We're going to discuss variation with time. So with time, O2 is increasing and this ozone is decreasing. Fine. Then it's the altitude. Altitude. Fine. This water vapor and dust particle decrease. Altitude means height. When you go upward in the atmosphere, the latitude dust particles they are confined in equatorial and subtropical regions, and the water vapor and the dust particles they are confined in subtropical regions. So this is all about the composition of atmosphere. Now we have the next topic, this structure of the atmosphere. So what we can do, we can discuss in the next video, or should we discuss in that much? It's about 40 minutes. Let me see, guys. I think it'll be better that we discussing. Okay, now we discussing this one. So next is structure of atmosphere. Then take it. Okay, now we'll discuss structure of atmosphere. Right? So These topics are important for 55. Structure of atmosphere. So, as we have physically, yes, fine. So, let's say this is our Earth. Fine. We know that around the region of gas we have this atmosphere. Fine. So this atmosphere is divided in two layers. We can say two parts. The atmosphere. The first one is, let's say, like that. Laminar is balloon visible. Right, like the dark one. Visible? No visible. Only. I guess now a little manually. This is our Earth. Fine. Okay, let me just make it with black only. No need of blue. Now it's fine. Yeah. So guys, this is Earth. Fine. Try to understand this. This is interesting and very important concept. Sometimes people often get confused here. So this is outright. The first layer we call it as atmosphere. The second one is atmosphere. What is atmosphere and atmosphere? We're talking about. Okay, guys, let me discuss between these two, atmosphere and atmosphere. So I'm gonna need some space here. So right. I'm gonna be here. Okay, here is some space. So atmosphere. And here we have this atmosphere. What's the boundary of the atmosphere? It is only confined to only 80 kilometers. Atmosphere is only up to 80 kilometers. Fine. And when you see the gases, the composition of the gases, and it up to 80, about 90 kilometers done. It is up to 92, where the limits of the atmosphere is there. Fine. Till there. In the atmosphere, the gases are uniform. What is the fact that in the atmosphere, the gases are uniform. They are mixed in a uniform mixture. But here, the gases are like in layers. They are in layers. So let me try this. So it is around 80 kilometers from above 90 till the limit of the atmosphere. So here uniform mixing of gases. Uniform mixing of gases. But here different layers of gases are there. I don't want this in space. I'm just going to create a table here. I will make it. Right. So this was fine. This is Earth. This is atmosphere. And this is atmosphere. So atmosphere and atmosphere. It is from 80 kilometers. It is above 90 kilometers till the extent of the atmosphere. Fine. Here the gases are mixed in uniform. So uniform mixing of gases are there. Uniform mixing of gases. Here gases are in layers. Fine. What else? Now, whatever the gases are there in homosphere, they are in molecular form. And in case of atmosphere, they are in atomic forms. Single or individual atoms exist. So you can write it like gases are in molecular form. Molecular form. But here we are only in the atom. Fine. Next difference, right? Let's talk about these dust particles and water vapor. So in this homosphere, the amount of water vapor and dust particles is higher as compared to this one, because we have just discussed in the composition of atmosphere that as we go up with altitude, the amount of water vapor and dust particles decreases. So it's the next difference. We can write it here like higher concentration of water vapor and dust particles. Fine. But here we have low concentration. Low concentration of water vapor and dust particles. Fine. So guys, this homosphere is divided into three layers. Now what are these three layers? These layers are troposphere, stratosphere, and then we have this one is mesosphere. Fine. Homosphere is divided into three layers: troposphere, stratosphere, and mesosphere. Fine. They guys remember, troposphere, stratosphere, and mesosphere are the part of homosphere. And then what about the heterosphere? It is divided into two layers. What are these two layers? Thermosphere and then we have this exosphere. Thermosphere and exosphere. Now guys, you have heard about this a term called as magnetosphere and then ionosphere. Fine. So guys, this is the exosphere. Right? There is a layer within this exosphere. We call it as magnetosphere. So magnetosphere is part of this exosphere. Fine. And one more layer is there, ionosphere. So ionosphere is both part of this. Ionosphere is ionosphere. Ionosphere. Ionosphere is part of both thermosphere and exosphere. Right? So you are writing like it has three layers. Let me see, is it visible or not? Yeah. So it has three layers. What are these three layers? Troposphere, stratosphere, Then we have mesosphere, but it has divided into two layers. What are these two layers? Thermosphere, then we have exosphere, and magnetosphere is part of this exosphere, and there is a layer between these two, ionosphere. This is both part of